Good morning. Today we are going to deal with cosmic ray showers. The last class we had studied what are cosmic rays, isn't it? Now you know the word meaning of shower. So today in this class we are going to deal with cosmic ray showers. Cosmic ray showers are air showers, or we can say it's a group of ionized particles and electromagnetic radiation discovered by Hoffman and Linton in 1928. And this cosmic ray showers was first detected by Bruno Rossi using GM counter. GM counter is a radiation detector, and with the help of this radiation detector, Bruno Rossi detected the cosmic ray showers. And the direct evidence about this cosmic ray showers was found by Blackett and G. O'Callaghan. So some people discovered, some people detected, and also given some evidence for this cosmic ray showers. But the main theory of this cosmic ray shower was given by Bhabha and Bhabha-Heitler. So Bhabha and Bhabha-Heitler developed a theory of the cosmic ray. Cosmic ray showers arise due to the interaction of cosmic ray with another particles, and they are producing new particles. So that is called cosmic ray showers. And we know that these cosmic rays are coming from the extraterrestrial sources like sun, stars, supernova explosion, and they are coming towards the earth. And when it gets incidence on the upper boundary of the atmosphere, it is known as primary cosmic rays, and when it enters the atmosphere, it undergoes several nuclear reactions and produces new particles. They are known as secondary cosmic rays. And these cosmic rays, secondary, will hit the ground but collides mostly with the nucleus in the atmosphere. And most of the new particles formed are pi mesons, and again undergoes collision, and now the particles formed are muons and neutrinos. And there is a theory which Bhabha and Heitler proposed, which is known as Bremsstrahlung radiation. That means pair creation of electron and positron occurs. According to them, a very high energetic gamma photon, gamma ray of the cosmic ray produces an electron-positron pair. And this electron and positron emit electromagnetic radiation, which is known as Bremsstrahlung radiation, when they move through the matter. Now these photons thus created will again produce electron-positron pairs, each of which again radiates. So this is a continuous process. And this process is known as shower, in which a group of electrons and positrons are obtained. I repeat, the cosmic rays contains high energy gamma radiations. So this gamma ray will produce an electron-positron pair when it travels, and that process is known as pair production in the presence of a nucleus. And the electron and positron thus produced will emit electromagnetic radiation when they move through the matter. So this process continues and we are getting a bunch of electrons and positrons, which is known as shower. So this is the theory made by the Indian scientist Homi J. Bhabha and W. Hitler in 1937. Now, what happens when this shower moves downwards in the Earth's atmosphere? The number of particles increases. We know that whenever this primary cosmic rays enters the atmosphere, it undergoes nuclear reactions and produce secondary particles. So more number of secondary particles are produced than primary number. So the number of particles increases as the shower moves downwards or as the shower approaches the earth, because more and more particles are there in the atmosphere. So these charged particles interact with the particles in the atmosphere and more particles are formed. So the number of particles increases as the shower moves downwards. Now, how many particles will actually hit the Earth's surface depends on the energy of the particle and also the type of incident ray as well as the ground altitude. Altitude means height from we can simply think it's at the height from the Earth's surface. So the number of particles hitting the Earth's surface will depend upon the energy of the incoming particle as well as the altitude. If large amount of particles are arriving, we can say it as extensive air shower. So when many thousand particles arrive at ground level, it is known as extensive air shower. See, in the left picture you can say a gamma ray, isn't it? Which is a primary particle. Now, it undergoes a nuclear reaction producing an electron and a positron. In the presence of a nucleus, there is a nitrogen 14 is there. So, in the presence of nitrogen 14 nucleus, this gamma ray split into, or the gamma ray materialize into an electron and a positron, which is known as pair production, which is the first interaction, and this process is known as Bremsstrahlung. Now again you can see that this positron emits a gamma ray. Also this electron emits another gamma ray. So in the second phase you can see two gamma rays produced, and these two gamma rays in the presence of another nucleus undergo pair production and producing an electron positron pair. So this process continues. So this is a development of a gamma ray air shower. Now what about our topic, cosmic ray air shower? So we have the primary particle, primary cosmic rays. On undergoing the first interaction with the nitrogen nucleus, which is present in the atmosphere, it produces several particles like pions also. Now what about this pion? Pions are the particles having very short lifetime. So they decay into muons producing neutrinos also. So these pions gets decayed into muons. On the other side you can see the electrons are producing. So several particles are produced after interacting the primary cosmic rays with the nucleus in the existing nucleus in the atmosphere. So this is the way in which we can get larger number of secondary particles which are known as cosmic ray showers. Already we had said that it was discovered by Hoffman and Lidum in 1928, and the scientists tried to measure the intensity of the cosmic ray showers with the help of ionization chamber. And when they used ionization chamber, they saw that there is a random increase in the intensity, and this sudden increase in the intensity of cosmic ray is known as cosmic burst. In 1931, Bruno Rossi experimentally showed the sudden increase in cosmic intensity were caused due to the production of new particles. The intensity get increased due to the production of new particles, and this theory was put forward by Bruno Rossi. How the new particles were formed? They are formed due to the interaction of cosmic rays with the nuclei or substances present in the counters used. So they initially used ionization chamber and also GM counter also. So what Bruno Rossi had done is that he placed 3 GM counters in a row, and he arranged this experiment in order to get the cosmic ray intensity in all the 3 counters, and his observation was a time to time simultaneous actuation to produce a coincidence pulse. Since he arranged it in a row, he didn't get a proper explanation from that, so he arranged it in a triangular manner. See, in the topmost left picture you can see 3 circles which denotes 3 GM counters denoted by C1, C2 and C3, and they are arranged in a triangular manner. Initially he had arranged it in a linear manner, that means C1, C2, C3 along a line, but he can't see any actuation in all the 3 counters at a particular time. So he made it in a triangular manner. Why he had made it in a triangular manner? See, whenever a particle comes from above, that particle can actuate or can activate only one counter, isn't it? And he placed a slab plate P above the counters, and the rays were incident on the P, and after that the particles get passed through the counters. So no single particle can actuate all the counters simultaneously. So he arrived at a conclusion that with the production of 2 or more particles, all the 3 counters can be actuated or activated. So in the picture given, you can see that if a single particle is coming from upward, it cannot activate all the 3 counters, isn't it? So at least 3 particles have to come down so that it can activate C1, C2 and C3. So what he had done, he changed the thickness of the lead plate P. So it was a lead plate, and then he made observations and it plotted a graph in which thickness of the lead plate is taken along x-axis and coincidence per hour of the counters along y-axis. And he got a curve like that, and that curve is known as Rossi transition curve. That is the variation of coincidence rate with the thickness of lead is known as Rossi transition curve. And in this graph you can see that initially the coincidence rate increases and it attains a maximum value, then it got decreased. So he concluded that cosmic rays which get incident on the lead plate produces a larger number of secondary particles in the lead plate, and so that these particles emerging out of the lead plate actuated the counters. Now what happens when the thickness of the plate increases? If the thickness of the plate increases, the secondary particles produced in the lead plate gets absorbed. So the graph got decreased. I repeat, Bruno Rossi had placed 3 GM counters in a triangular manner, and he placed a lead plate above these counters and studied the variation of cosmic ray intensity, or we can say the coincidence rate in the GM counters. So the cosmic rays which get incident on the lead plate produces secondary particles in the lead plate, and these secondary particles coming out of the lead plate actuated the counters C1, C2, C3, so that the graph started increasing and it attains a peak value. Now what happens to the graph? It gets decreased. What is the reason of the decreasing region of the graph? So when he increased the thickness, you know that the thickness of the lead is increasing, isn't it? So whenever the lead thickness is increasing, the secondary particles produced in the lead plate gets absorbed in the lead plate, so that there is no particles coming out of the plate P, so that the coincidence rate got decreased. This explains the nature of variation of the coincidence rate, and this graph is known as the Rossi transition curve, in which the counting rate increases and then decreases with the thickness of lead plate. And more evidences were there using cloud chamber also. Cloud chamber is another radiation detector. In 1933, P.M.S. Blackett and G. Calini found the evidence of cosmic ray shower in metal plates by using cloud chamber photographs. Both positive and negative particles were found to be present when cloud chamber was placed in magnetic field. When the plate number increases, that means when the thickness of the plate, we can say the thickness of the lead plate increases, shower particles also increases. But for large thickness, the shower size begin to decrease due to absorption. And such a type of shower is known as cascade shower. That means initially the shower increases due to the production of secondary particles. Later on, the shower got decreased due to the absorption of the secondary particles by the lead plate, and this type of shower is known as cascade shower. So this is a picture showing the cosmic ray showers. Initially you can see the white color in less. Then you can see there are lead plates. So as they are coming towards the lead plate or through the lead plate, you can see the increase in the white color, which is known as the cosmic ray showers. And later on, when they get passed through the lead plates, this shower gets decreased. So this is the cosmic ray shower theory developed by H.J. Bhabha and W.Heitler in 1937, in which very high energetic gamma ray photon of the cosmic ray produces electron-positron pair in the presence of a nucleus, that is in nuclear field of an atom of the material through which it travels. Thus they emit electromagnetic radiation known as Bremsstrahlung radiation because they got deaccelerated when they pass through the matter. Decelerated. And thus produced photon possess enough energy and they further produces electron-positron pairs of which again radiates. And this process continues until their energy gets lowered. And this is the theory of cosmic ray shower. See, initially you can see a single line. Then after that the line gets spread because the secondary particles formed. Now later on this width of this spread gets decreased due to the increase in the thickness of the lead plate as done in the experiments, which causes the absorption of secondary particles. So in the right picture you can see a white light that causes the cosmic ray shower. Another picture showing the primary cosmic rays and the production of a secondary cosmic rays, which are known as cosmic ray showers. I think the session is clear to you. Thank you.